Okay, here. So yeah, let's get started guys, without any further ado. I guess you have attended the session yesterday as well. As discussed, today we'll be starting with our first topic in cybersecurity, networking fundamentals. Now, this is a prerequisite required in cybersecurity, understanding what networking is, what are networks and what are devices, and how do these devices communicate with each other, primarily using something called IP addresses. So when you talk about networking fundamentals, as mentioned, we need to know these definitions first. What is networking? What are networks and what are hosts? So basically, when you talk about networking, this is the practice of connecting information devices with each other. Okay, now these devices could be anything, as small as a mobile phone to as big as a web application server or a database. So the practice or the process, I would say, of connecting these information systems with each other so that they can share resources or data is called as networking. Now, when you have a collection of those devices together communicating with one another, that collection or that group is called as a network. Okay, just like how we have a network of people that we know or we communicate with on a regular basis, similarly these devices connected with each other is called as a network as well. Okay, and each of the devices in that network individually is called as a host. So host refers to any device connected to that same network which can transmit or receive or send data to others. Okay. Examples: your computers, your printers, routers, mobile phones, IP cameras, headsets, whatnot. Okay, whichever device is capable of sending and receiving data from other devices is called as host. Now, just like how we communicate with each other and we have our respective names to address each other, similarly these devices also have their own names or identities, and that identity is called as an IP address, Internet Protocol address. Now, this was developed by the US military late in the 1950s or so, and during the initial phases there were various versions of it, experimental versions. There was IP version 1, IP version 2, IP version 3 as well. They were quite experimental, as mentioned earlier. They didn't work out properly. Okay, what successfully worked out was IP version 4, and we're still using that address, that category of addresses even in today's world. Okay, and in short, they're called as mentioned, IPv4, which stands for Internet Protocol version 4. Okay, so again, to define an IP address, every host on the network has a unique identifier. Okay, and that is known as an IP address, and this allows for communication to occur between these hosts. Okay, now this IPv4 address specifically has a few properties to it. First things first, this is a 32-bit address. What I mean by 32 bits is that each bit is either a value of 0 or 1. So the maximum data it can store is these two characters, either 0 or 1. Okay, that is the smallest data structure a computer understands. Okay, and your IPv4 address contains such 32 zeros and ones. Okay, and this 32-bit address again is actually divided in 4 equal parts, where each part consists of 8 bits, and that 8-bit portion is called as an octa in the sense 8. Okay, and each octet is divided by a dot symbol. So therefore, this is what typically your IPv4 address looks like. As you can see, a combination of zeros and ones, which are actually in number of 32 zeros and ones, and each of that 32-bit address is divided in 4 equal parts again. Now, what you see here is commonly known as the binary language of zeros and ones. But we humans don't understand binary so well. It is something which is simply understood by a computer, but not so simply by humans. Okay. What we regularly use are decimal numbers like these. So now we're going to learn how do you convert any binary number to a human readable decimal number. So this number here, 11000000, is actually equivalent to something like 192. Okay. So we'll understand now how do we perform that conversion. Okay. So this number 10101000 is actually equal to 168. All zeros is equal to 0, and 00001010 is equal to 10. Okay. So let's talk about that conversion now. But before that, any questions or doubts up to this point? Arun, Umesh.
Yeah.
As you questions, let's progress further. Now, as mentioned, let's talk about the conversion. So whenever you want to convert any binary number to human readable decimal number, so rule number 1, let's say, assume if you take this binary number here, 10101010. Rule number 1 is you assign the power of 2 to each bit from right to left. So the rightmost bit will have key part 0 under it, and the leftmost bit will have 2 power 7 under it. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, as such up to 2 power 7. Okay. Now, the reason why we have 2 power here is because again, all of these are binary numbers. You only have 2 possibilities. Just a second, there's some background disturbance. Arun, you can mute your mic. If you have a question, please feel free to unmute. Right, thank you. So again, once you have written down those numbers, guys, all you have to do is multiply the lower bit, okay, the lower power with the top bit, okay, and keep on adding till the last number. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So again, as mentioned, multiply the lower power with the top bit and keep on adding till the end. Okay. So if we calculate this number now, let's try to understand the values for these numbers first. Anything to the power 0 is always equal to 1. That's a mathematical rule. 2 power 1 is 2. 2 power 2, which is like 2 into 2, that's 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Okay. So simply now 2 power 0 into 0, that's 0 itself. Plus 2 power 1 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. And 2 power 7 into 1, that's 128. Okay. So we add all this up. 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it or understands it as 10101010. Something like high frequency, low frequency, high, low, high, low, high. So when it sends those electrical signals in those exact frequencies, it understands the number 170. Okay. Is that clear, Umesh, Arun?
Yeah.
Right. Perfect. So if you've understood this number, guys, I have a few examples here. If you have a pen and a paper beside you, or a phone at least, can you calculate the answers for these numbers and give me the final value? So again, as you can see, these are two examples: 0, 1, 0, 1, 0, 1, 0, 1, and all ones. And once you give me the answer, I'm going to explain you how this is helpful for us, or why do we need this logic. So I've written down the values here, guys, from 2 power 0 all the way up to 2 power 7. So I want you to calculate the final decimal number for these binary numbers. Example 1 and example 2. Take your time, no rush.
Sir, actually, I'm in a traffic. I can't.
Yeah, that's okay. No problem, that's okay. Umesh, you can give me the answer.
Yes, sir.
Take your time, no rush.
For example 1, it is 85. For example 2, it is 255.
First one is how much again, Umesh? Your voice is very feeble. Can't hear you properly. 85. Okay, we'll check that. Second one?
It is 255.
255. Yeah, perfectly right answers. Again, as you can notice over here, simple logic: 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0 plus 2 power 4 into 1 plus 2 power 5 into 0 plus 2 power 6 into 1 plus 2 power 7 into 0. And if you add it up, you should get 64 plus 16 plus 4 plus 1, that is 85. And here you just add all the numbers: 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, and that gives you the number 255. Okay. Now, if you ever ask me why this is needed, why do we again need to understand this? The reason I've been explaining you all this all the last few minutes is to understand the range of IP addresses. Now, if you had to get to know what the first IP is, all you have to do is simply put all zeros everywhere. So in the first octet, all 8 zeros second octet as well, all zeros, third and fourth octet as well, all zeros. And now when you convert that from binary to decimal, you get the first IP as 0.0.0.0. And if you have to get the last IP, you would simply put all ones everywhere. Okay, in the first octet all ones, second octet all ones, third octet all ones, fourth octet as well, all ones. And now when you convert that to decimal, you just gave me the answer as 255, right? So the last IP is 255.255.255.255. So now we logically know why IP addresses cannot exceed the number 255, because when you put the maximum value of all ones in a binary octet, you would only get 255 as the last number. You cannot exceed more than that. So you would never have IPs in the negatives or in the numbers above 255. Any octet will only range from 0 to 255. Okay. And if we had to calculate how many IPs are there in total, if you notice over here, there are 32 bits. And each bit has two possibilities. So 2 into 2 into 2 into 2 as such to the power 32. So if you have to get the total number of IPs, you can get that with a simple formula of 2 to the power 32 or simple calculation of 2 to the power 32. And that would give you a number approximately 4.3 billion IP addresses. Okay. So again, that is what the total number of IPs are in the entire range from the first IP till the last IP. Okay. Now back then when these IPs were invented in the 1950s or so, 4.3 billion IPs was definitely a very large number, subjectively speaking about 1950s or so. But fast forward to 2024 today, population itself is more than 8 billion people, and each person again can have multiple devices, right? So you could have a phone, you could have a smartwatch, you could have a laptop, you could have a smart TV, and each of these devices definitely requires an IP. And as such, if you keep going on assigning every single IP to every single individual device, 4.3 billion IPs are nowhere sufficient. Okay, so that is why, as mentioned, we have a concept called mapping, dividing these IPs into different categories again: public IPs, private IPs, classes A, B, C, D, and so we'll talk about those categorizations later on. But before that, let me talk about one more last concept for today, which is sequencing of IPs. Now we know what's the first IP. We also know what's the last IP. But what about the IPs in between? What is the sequence of that? Okay, so let's talk about this now. So to understand the sequence of IPs, there are two simple rules again. Rule number one is you start incrementing from the rightmost octet first. Now what I mean by that is, if I show you this with a list of IPs, just a second. Yeah, much better. So now we know this is the first IP here, 0000. And if you have to get the next IP, guys, rule number one, you always start incrementing from the rightmost octet. So the rightmost number here, the last octet will increment by 1. So after 0000, you have 0001, then 02, then 03, then 04, then 05. As such, it will keep on going until the value 255. Now please note, as mentioned earlier, after 255, you cannot have a value like 000236. This is not possible. It's a wrong IP. Now once you reach the maximum number there, then comes rule number 2. So once the rightmost octet has been completely filled, once it reaches the maximum value, then you move to the left octet. Okay, so now this left octet here, the one beside the rightmost one, increases by 1. Okay, so this 0 now changes to 1. And this 255 cycles back to the first number, 0 again. So after 1, 0, you have 1, 1. Now don't make the mistake of going to 0020. That would be wrong again. Remember rule number 1, always increment the rightmost octet first. So after 1, 0, then you have 1, 1, then 1, 2, then 1, 3, then 1, 4, then 1, 5. Goes on all the way up to the value 1, 2, 5, 5. Now after 255 again, this cycles back to 0. And this 1 now changes to 2. So you have 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, goes up to 2, 2, 5, 5. As you can see over here, there's a pattern forming. 0, 0 to 0, 2, 5, 5. 1, 0 to 1, 2, 5, 5. 2, 0 to 2, 2, 5, 5. 3, 0 to 3, 2, 5, 5. 4, 0 to 4, 2, 5, 5. 5, 0 to 5, 2, 5, 5. And like that, it keeps on going all the way up to 2540, 254, 255, 2550, 255, 255. Now both these octets are filled. What happens now? These 255 cycles back to zeros. and this 0 now changes to 1. Okay, so now you again have the first number 0, 0, which goes up to 0, 2, 5, 5, then 1, 0, up to 1, 2, 5, 5. Like that, the cycle keeps on going from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. So as you can see, there's a newer pattern: 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 3, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 4, 0, 0 to 4, 2, 5, 5, 2, 5, 5, 5, 0, 0 to 5, 2, 5, 5, 2, 5, 5, 6, 0, 0 to 6, 2, 5, 5, 2, 5, 5. Goes on and on and on and on. And somewhere down the line, you'll have 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5. And once all these octets are filled, this 0 now changes to 1. And whatever pattern repeated here from 0, 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5, same pattern repeats again from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 0, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 2, 5, 5, 3, 0, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 2, 5, 5, 4, 0, 0, 0 to 4, 2, 5, 5, 2, 5, 5, 2, 5, 5. As such, down the line, 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. Here's the first IP, and here's the last IP. Okay, and if you count each and every IP along the line, you'd get a total of 4.3 billion IP addresses, and that is the entire sequence of IPs. Okay, from the first one till the last one. Okay, now I'm going to explain it in the next class, guys. Why do we have this importance of sequencing? Okay, but again, this is a brief idea on what those 4.3 billion IP addresses are. Okay, any questions, any doubts up to this point? Arun, Umesh?
No, sir.
No.
Right, perfect. So as mentioned again, these 4.3 billion IPs are again divided in multiple categories. There's something called as classes, class A, B, C, D, and E. And then again, each class has something called public and private IPs. So we'll talk about all these categorizations in the next session. What are public IPs? What are private IPs? Where do you use these classes? Okay, what are the ranges of these classes? Okay, again, what are ranges of public and private IPs in each class? And what are the importance of these classes? How they're unique to each other? Okay, what is the property of each class? So we'll talk about all these advanced concepts in the next session. Okay, in tomorrow's and day after tomorrow's class. So yeah, again, nothing further for today guys. This is about it. A brief introduction to IP addresses. We'll talk about all these advanced concepts in the upcoming sessions. Okay, so that's that. Thanks for joining this session today. We'll connect back tomorrow and cover these advanced concepts. Yeah, thank you. Have a good day. I'll see you tomorrow at the same time.